I'll be speaking about the profession of data science and how data science applications can help us gain insight and be more efficient in our activities. So, what is data science? It seems to be like something that is a buzzword recently, and there's so many definitions. You hear machine learning engineer, business intelligence, and so many more like terminologies. So I think the best way to describe data science is a multidisciplinary field that requires some mathematical and statistical knowledge, computing skills, and domain expertise. So the truth of the matter is a lot of people actually are what you might say they're practicing data science in their day jobs, or I'm sure we have a lot of academics here. I'm sure they practice a lot of they use a lot of data to drive their decision making and their experiments and research. So the field of data science differs from computer science, as computer science focuses on processes and the design of scalable algorithms. So computer science is normally concerned with how can I make an interface that allows people to network? How can I make an interface that allows people to apply for jobs and stuff like that? While data science also has relationship to statistics. While on the other hand, the statistician is always more focused on what does the data says about what does the data set say? What does the data I'm observing says? What's the mean of the data? What's the variance? What statistical tests can I do on the data? It's not really focused on the practical application of what I can use the data for, or what value I can get out of the data. In contrast, data science focuses on the extraction and creation of knowledge from data. It's honestly not a field that just pops up recently. I think it's something that has been around for quite a long time. People have been practicing data science. So on the left here we have a map of London that John Snow used to prove that like cholera is a waterborne disease, and the areas of London that are most affected, which are the areas that have like linkage towards the sewage disposal system. So we can see, is this something that like modern businesses have, like business intelligence analysts that allows them to gain insight basically of just visualizations that of the business for the data generated by the business processes. Another example would be the discovery of a planetary model. So there were a lot of like models that were suggested like throughout history, from the Earth being the center of the universe and the sun being revolving around it. And a lot of scientists came and using data, they proved like, okay, this assumption is wrong. We have to go back and build a model that basically that tries to agree with the data that we're observing. So it's quite a process that has been around for a long time. And this is Sir Isaac Newton. He was famous for discovering calculus, law of gravity. So calculus is one of the essential tools of like modern AI, which is neural networks. So calculus is integral to training neural networks. So we can see that the field of like data science has been around, and it's a tool that scientists and problem solvers have been using all throughout time to pragmatically solve problems. So what's the data science process? So any data scientist you will ask to tell you the main process they go through is they get the data from somewhere, they clean it, organize it, they parse it for some pattern, maybe visualize it, or have some analysis that they do to give to extract the important information out of the data. And after that, they sit down or to do what we call arithmetic, which is basically build a model of how this data is generated or how the input variables add up to give you an output variable. Nowadays, like modern artificial intelligence is capable of quite a whole lot of things, and the practical applications of it are quite enormous. So we can see it ranges from self-driving cars to reinforcement learning, where we have kind of a model of how the human brain works, and it's applied in many like game environments and even like to train robots and stuff like that. We also have the application of artificial intelligence in medicine. So this is a picture of AlphaFold, a model for that like recognize protein structure or based off the amino acids that are in that protein. So this is really helpful for things like drug discovery, stuff like that. Basically, it can help you design antibodies that would have fight specific disease and stuff like that. We also have the field of natural language. So we have reached the point where we have models that can easily understand human language. We have human assistant on our phone with Siri and Google Voice. And it's used in several other fields such as text summarization, like in the law, people collect a lot of documents, and to actually pass this document is actually a task that requires like a lot of paralegals and stuff. So having LLP in that field assists in like extraction of valuable insights that in the documents. So what does I'll be going through like a practical demonstration of what a data science or artificial intelligence process looks like, so we can all get a practical sense of how data science is being applied to problems. So the problem I'll be demonstrating is called the Eminence Problem. So it's quite famous in the field. So we have handwritten digits from 0 to 9. So this is a random. Scroll down. Just scroll. So a sample of the data set is here seen from 5041. So this is just a random sample of the data set. So we're going to train a computer vision, or not really a computer vision, just a neural network to be able to take an input image and learn to recognize what digit it is. So the process involves like getting the data. So this first bit of code is doing, just showing you how you get the training data. So the training data is basically is the inputs and the outputs. So we can see the X train, Y train. And whenever we make a data science application, we want to have a way of testing it. What does it do on data that it has never seen before? So in this file, we build our model. So over here we build our model. So we need to tell our model like what are we expecting as an input. So this the first definition here, sub.x equals eminence train. So we're telling them we're taking in an input of floats, floating point, which is basically a number with an integer and also a decimal in it. So once we build our model, the next step is to design the training process or the learning algorithm, as a terminology that's commonly used. So the important thing here is to set a criteria for what's a success criteria, or how do we measure success. So there is a criteria, which is this entity, uh, this entity score that measures how far you are from or the ability. So every time the ability of the ability that you feel like the ability of the numbers of the you feel like the ability level is one, you feel like the ability level is zero, or zero level is and our experience just measures how far away you are from that probability measure. So if you set zero and you predict a one, so you have a high loss. And if you see a zero, you predict a zero, so the loss will be zero. So once that's done, we need to basically design, we need to tell it for how long we're going to train our model for. So that's the number of epochs. And once we we set the number of epochs is to basically go through feeding the inputs into our model and telling it to make a prediction. So once you feed an input, we got what the actual, the true value of what that prediction is, which is the label. And here we measure the loss, which is basically how far away are you from the true value. And the next step is to go through, once you obtain the loss, is to feed it back to your model and say, hey, this is how wrong you were. Can you adjust your parameters so you can be more right next time? So this is essentially the process that powers a lot of what we see as what we call modern AI and stuff. The ability to allow it to train itself. So we can see the difference here between the field of statistics and data science. So using the data, we're able to automatically extract inputs due to like being able to have much computing power. Nobody tells the algorithm that you're wrong. It already knows the answer based off we have the true label from the data, and it can measure how far away it is from that true answer. So it's just very much like how we ourselves learn in school and stuff. We get a test. If we fail that test, we know, okay, these are the things I got wrong. These are the things I need to study more. So this is essentially the same process. So as you go through that process, the important things to record is the loss, as I mentioned, and how well does it do of data it has never seen before. Maybe can you try running the first, first click enter? Press. Yeah, the first one, the first one. Let's play out. No, play the next one. Yeah. Just press play on all of them. No, it has to be in order. Can you push it? So, sorry about the technical issue. So, the next graph just shows you how you measure this training loss across your across the number of epochs you choose, and this is how you optimize your model to know that it learns how well it learned the task you assigned it to them. Basically, how well are you able to minimize the training loss? So yeah, that's it. You have any question?
If we can start by some of the participants have no computer science background.
Yeah. So as I was saying, like it's a field that basically tries to automate or some of the inductive processes that are in statistics and stuff. So we automate the statistical process so that we can automatically derive insight from just having data alone, without actually having to have someone analyze the problem or a computer scientist sit down and design a solution to a problem. Any other question?
Can you just like some live examples where you could use model like
Yeah, so an example of what we can use, an example of application I showed is image classification. So one example is in hospitals where we have X-ray images of patients. We can use them to diagnose what's the prognosis of the patient. What is a certain like mass cancerous, or is it benign, stuff like that. So we can automate some of this process. Another example would be like self-driving cars. We can identify what's on the road. Can you identify the cars on the road and any obstacle on the road?
So just some follow-up about the person was saying about having some of the participants who don't have a background in computer science. So what kind of step should they take if they're interested in going to becoming a data scientist? So listening to you, and some of them are a bit interested, and some of them are confused about what language are you really speaking. They don't understand. They don't get you very well. So, in the layman language, and also what are the steps they need to take in terms of preparing themselves to be also to have this kind of like prepare themselves to become a data scientist.
Okay, so like the slides I showed, the steps need there is like so data science is a pragmatic field. So what you need is to have a problem in mind and basically data around that problem. So you need to be creative to know to see which statistical test should I perform on this data, to gain a certain insight. So you need to have assumptions of your own. What's the most, if you're testing, if your data is categorical, what's the most prevalent data is what's the most, let's say it's gender, it's like female, male, what's the most prevalent gender? Is giving you a population. So you also have to have the statistical knowledge to take out a statistical test on that data to say, okay, I can make this assumption about the data I'm looking at and test the assumption like we've seen with the previous example of Just Know and Isaac Newton, where they use data to test some of the assumptions they have about like how does planetary model works, or how does where in London do people have cholera most, and so all this kind of creative approach to looking at data is it's really helpful to start out as a data scientist.
What are the pathways of becoming? So what's the pathway of becoming a data scientist? Data science person. And what are the other application of data science? And data science, what is the application of data science for anything?
So to be a data scientist, it's really or to apply data science in your organization. It's really more about how you organize yourself. Like we see, it's not something that you just have to have. If you're a statistician, you don't just become a data scientist, or you have the domain expertise. It requires collaboration, which is like understanding the underlying data you have, and also carrying out those statistical tests that we mentioned to ensure that the assumptions you make or the model you have that that you model you get after is actually the correct model, is doing what it says. So like we saw with the solar system model, so some people showed like the Earth is the center of the universe and everything revolves around it. So this scientist says like, okay, we observe like which point we see Mars rise from using the telescope and stuff, and they said, oh, this data does not really like fit in with what we have. So is the data wrong or is our model wrong? So these are the sort of questions an organization would have. And for the applications of it, it really depends on how creative you are as a company. So we can see companies like Facebook, Google, and so many internet companies that have ton of data. They're leveraging this data to get more users, to offer more better services to their users, to understand what their user needs are, and so on and so forth.
Maybe you are not getting what the audience wants to hear. What we are saying is, I'm not from the computer science. Okay, can you in this form now? Let's assume you want to predict that will someone get admission into a university with his or her mark. That's to predict if someone will get an admission into the university. So if an average person, if you can tell us, for example, in software development, if someone wants to learn software development and is not from computer science, it's first of all tell you the output of being a software developer, and what he or she is going to learn, how he or she is going to do. So, for example, let's take a practical example here now. Is computer science all about knowing our agenda? Is it about predicting? And if you have to predict, how do we do it practically? That in such a way that you won't You won't use those computer. You will come down to an average person's level. That's what I'm thinking.
Yeah, so the gender was just an example. So given a data, you have a lot of attributes or variables. So attributes are like stuff that describe specific samples in your data. So you're not really focusing on one thing, you're focusing more on the population. So let's say, like you said, predicting whether someone will get an admission. The first thing you start is what's the admission rate? So I have data of, let's say, 10,000 students. What's the probability given a random student that person will get admission? That's where you start. And then you look at other variables that affect it. So if I don't look at, so let's say I look at gender and admission now. Okay, maybe females are getting more admissions to universities. And then you look at other stuff like that. What background do they come from the arts or science background? So something along the line.
So, I think to what person is saying, it's all about if you have an organization and you have data, doesn't matter what data it is, and you need to improve whatever you're doing. I'll give you an instance. People in the insurance sector, they wanted to predict people when they come to take a loan from us, and this person pay back. And what data point do they have around this person? So what they could do, it could be that they will scrape, there are ways you could scrape people, right? You scrape all those data, and they gather all of them, put it into their model. It will crunch and give credit scores to different people based on data around you. So you see, you have data, you've been mining all this, you're getting people data, information, this person, for they know, it could be age, it could be demographic, it could be so many things. You get that the features is talking about. You get all those features and put into the crunch it, and be able to predict. That's when you can apply like something money. There's this brain money. Yeah, you don't your food, don't buy it. No, you don't talk to anyone. Yeah. Automatically, they grant you or not grant you. Yeah. So nobody's looking at you. Okay, what happened? No. It's all the AI is doing that automatically. Credit scoring. Yes, you do that. Even job application, I would say people that there's a certain time of the day, you can submit it midnight, afternoon, all these things are data. So if you are in any organization and you are showing out data, all right, and you're looking at how do I use this data to improve what you are doing, at that point, data scientists come in. They gather all your data and analyze them and do what they have to do. Then give you out. So next time someone will just keep in those data and say, oh, do this and do that. I think that will happen with you.
I answer my questions. But what I ask is that what is the pathway for becoming a data scientist or non-computer science person? If someone who is not a computer scientist, what to become exactly? What is the insurance pathway? How
like modern day like data science or the amount of data we have now.
How did you become a data scientist?
Yeah, the amount of data we have nowadays is like you need some form of like computation skills to be able to process it. So there are so many tools available out there. So you need to understand like what is the relationship between like variables in the data. How can you analyze data to gain insight? But the automation of the processes that analyze data is quite simple. So it's just being someone who regularly handles data, knows like what can go on with like making predictions or making assumptions from data. So you might get data and because of the way the data is recorded, there might be some bias in that data itself. So you need to be able to like mitigate like your model so that it does not have bias as data or test your data for biases and stuff like that.
So, yeah,
again, it's facts. You need some coding skill. And one common one is Python. And Python, for instance, you don't need any expensive training for that. It's very easy. But Python, you code it as you, if you write it, you code it, you do it as if you're saying the way you speak, the way you think, flows natural like that. So I would say getting some knowledge of Python would be. And now they have all kinds of models already. You cannot want to do it for just to have it. But when you do everything, you know, they don't do your coding just so you somewhere you was running some stuff there. So okay, this thing is better. You know, just to know this that. So I think not having that within background and all the tools are better.
And you don't just need to be a data scientist, you need to have information on what domain you're actually practicing. So if you're predicting, if you're a banker, you'll be able to make maybe loan processing applications better, like Mr. just mentioned. If you're a doctor, you need to understand where some of the misconceptions your model can make, or some of the biases that can appear in the data.
Yeah, and also to add more, you cannot just be a solo in data science. Yeah, just to add more, you cannot just be a solo in data science.
Yeah.
And then we are in university, run projects which you actually work on. University are encouraging collaboration, also doing things beyond just within your own. So you may think of how do I build this team. I think it would be nice if you can talk around that. How do we build a data science team?
So I mentioned that data science is a pragmatic problem solving tool. So to be a problem solver, like you need to define what the problem you're solving is, and you can only do that with the help of someone who has some expertise in the domain and a range of opinions. So we can't really unravel everything that's in the data. So you as a data scientist can carry out all the statistical tests you can or you want to, but someone with an expertise will come and tell you, say, hey, if someone is between this age and this age, and their body mass is so and so, and there's this in the X-ray, like this is more of a sign that they will have cancer, and the model might not be able to pick up on some of those things. Or like in education, if you're going to predict if someone is going to fail a class, something like that, regardless of the data you have, your model isn't going to be perfect. You might classify some people that are quite high achievers as at the bottom of the class. But a teacher who understands how human learns, with years of experience, will always tell you that, hey, this is a misconception you're making, or this assumption is wrong. Regardless, like I said, the data is always biased based on how we collect it. So that's one additional thing that people who are have expertise in a domain will inform how to collect the data, or what you need to remove from the data, and things you need to consider when making decisions. Data.
Most importantly, I think a lot of the audience, because the demographic of the environment we are, education learning environment, data scientists is the job of the present and the future, which actually has different verticals. In as much as a data scientist, you can play in different fields, different organizations, be it a solution that's in educational environments or agricultural environment that's in a farm, or in the digital marketing or e-commerce platform, or different platforms, be it in the kind of organizations you want, you can fit in to be able to provide those services. So it depends on how you prepare yourself in terms of the tier of learning, right? Every learning skill has its own stages. As an early stager, if you're an enthusiast, you're very interested in becoming a data scientist, there are steps to take in preparing yourself and equipping yourself with the right skills so that you can be able to match up for that. But I believe it's something of interest that we want a lot of more people to fit in so that they can be able to, because we have very few data scientists. A lot of people talk about every day that there is no job, but there are jobs, but there are no right people to get in that jobs. That's it. So please try and subscribe and learn and become more data scientists. That's it. That's what I'm going to do.
Thank you, everyone.